Well, hello, everyone. We'll go ahead and get started. It's nice to see you all. As always, I like to open up in prayer. I'll give a few announcements, and I'll also make sure that I send out an email and announcements so people are aware of some of these details that I'll be passing on. So, dear Heavenly Father, Lord, it's a blessing to be working with each of the students in this course. I pray that you would be working in them as they are learning the technical skills that they will be needing to become proficient in their field of choice as they move forward. And also in their time at APU, that you would help them as they're getting a chance to learn more about Scripture, more about the theological concepts in which you want to be guiding our lives by. Bless our time. In Jesus' name we pray. Amen. So in terms of announcements, it's a blessing to have you all, and I want to make sure that I'm able to communicate and help you all learn the material. And so I think we found a bigger room that we'll be able to use. And so next Tuesday, we will be meeting in Building 1 in room 224. For folks that might be familiar with it, it's a computer room that they have there. And so I think that'll be nice because I think it has a total capacity for 30 people. It'll be a little bit different of a configuration. It's actually has a raised floor, and it's kind of set up for people to be doing programming, which is actually what we want to be doing. So maybe that's not such a bad thing after all. So that's the main thing that I wanted to pass on. And the main focus that I wanted to have today was to help you all get your Eclipse environment working and getting a chance to import and starting to play with the sample project that I shared with you. So what I'll do is, first of all, I'll start with just, can people let me know does everybody have Eclipse set up on their computer? If you want to be using a different IDE, that is fine, but that's the one I'm going to be showing, and so it might be a little bit easier for you to be watching what we're doing there. So maybe I'll stop sharing my screen for the moment here and just do a quick roll call. Everybody have an Eclipse environment that's working? You can either use a chat or give a thumbs up or however, go off mute and just say so.
Yeah, my Eclipse is working, Professor.
Okay, good. I'm seeing a lot of thumbs up, so that's really encouraging. And for a few others that maybe if you're still trying to get things up to speed, let me know, and I'll be glad to work with you to try and get the bugs out. So why don't I do that first, and I'll focus on getting us up to speed with the Eclipse. And let me point out a few resources. Now with this lecture, I'll go a little bit deeper into talking about it. So we have all the resources that we have in our textbook, and in a second, I think I'm still full screen mode on my charts. I don't know what course. Okay, so you want to be downloading two things for the code. You want to be downloading the sample bag source code. That would be number one. And also, you could get it from the website as well, but I went ahead and got it here because the authors and the publisher are trying to make a lot of information available for you. And so this is all the sample source code that's included in the textbook. And so that might be helpful for you, especially in the beginning. The code that they have is fairly complete. And then as they get more complicated, they don't repeat all of the source code for things that they covered earlier on, but they focus on the new things. And then you have to stitch it together with stuff that they've already covered. So there are some introductory videos that might be helpful for you. These are, for this is just a link to a lot of the online materials that the publisher made. It's also included in the the lecture notes that I have available that I've included. And so this is the lecture notes. This is a copy of the PowerPoint presentations that I use. And this one is, as I mentioned last time, was a couple introductory videos that if you haven't figured out how to be using an interface, which is one of the things that'll be a little bit different that we'll talk about today, we'll go in and try that. And then there is a lot of video content. And so for each chapter, what I did is I took the lecture notes and I annotated it with stuff from the textbook. And so you're free to look at those. But once again, I also include for each chapter the video notes that the publisher have been available. And I will show at least one of those today, so we can get a chance to see what that looks like, and hopefully you're able to hear it clearly, and you also have access to those videos. So that's just a little bit of a heads up for a couple things that I wanted to share. So once again, double checking, has everybody been able to import this project into their Eclipse, or do you need me to walk you through how to do that? Basically, what I found is once you unzip it, you can actually, you want to be creating a new project. That's what I'd like to do. I've seen some people that they just create a sub project. Way I've done it, I've just parsed it into individual projects, and then I have things focused on one thing at a time. So one chart that you'll see a lot, and then I'll just pull it up here, is this chart. So the first thing I'm going to talk about is this interface. And from that, what I'm going to do is to show how you can generate the code stubs and begin to start to focus on the implementation. And so this is one of the purposes of what an interface does. In C++, it would be called a header file, but it's called an interface in Java. And so that's what we're going to be leveraging here as we work on this material. So I click on that interface. The way that it's shared in the textbook is they have a lot of useful descriptive information, but what I did is just I boiled it down to just the bare minimum, and I'm going to show you what you can start to be doing with this as you start to work with these details. So let me go ahead and create a new class. Okay. And what I'm going to show you is how to link this interface with that in case you haven't seen that. And so the convention that the authors use, which I think it is really quite helpful, is to specify, well, what kind of, if we're going to create a bag, well, what kind of a bag are we going to create? And so what I'm creating here is an array bag. And so this is starting to get into the details about what I'm going to do for the implementation. So you can keep that in mind. You can do whatever you would like, but I'm going to be using that convention. I already have this done on another one, but I'm just going to create a new one to show you what I mean. And here is another trick, is you want to be adding the interface. So then you want to do that. And you want to be looking for this bag interface. So we'll use that. And what this will do by putting in this interface, it's going to actually create some code stubs that are going to be quite helpful for us as we get going. Another thing that we don't want to put is we don't want to put the public static void main. We don't want to have the main, because this is just the implementation of the interface. This is another way of how things are split up, the way that the coding approach that we're getting a chance to see as we work through this course. Okay. we get a couple of error messages here. Just so we want to add the unimplemented methods, and this is where you get the code stubs because it's doing that implement. So that's the first thing that is that we need to fix. And so these are all of the methods that have to be implemented. And the second thing that needs to be done is we're still getting an error message. And we haven't talked about this yet, but this is a generic type. And so we need to be doing that same thing here. So an angle bracket T. Okay, so that's how we start to get the shell that we would be using for doing our coding. So let me make sure I have my chat open to see if I get any questions. Okay, I see your message. Gerald, it sounds like you're having problems finding the bag interface. Did what I just do, did that help you find that? Okay, thank you. I appreciate that. I do much prefer to have some active engagement, so feel free to do that. I'm going to go ahead and delete this one because I already have something doing this, and so I'm just going to go and get rid of that file. I'll open up what I had. So delete that file. So this is what I gave to you. It has these files. And so the first that you see this interface, the stripped down interface, and the next one is exactly what I showed you was this same type of bare minimum thing that has a code stub for all of the methods. So what we're going to find out is there's actually more methods in this than there are for some of the next abstract data types that we're going to be exploring. But this will at least give you an idea, something to think about. And so this really isn't going to do anything. And so what I did is I created another one where I fleshed out a little bit more. And mostly I just put in print statements to that when you call something that is going to let you know that it's actually been executed and it's starting to work out. We also see some other information up here. We need to be declaring a couple things. So we want to create an array that we're going to store the bag elements. We have that. There's also oftentimes what they do with their approach is they have a couple of things, oftentimes having more than one constructor. And one constructor can be leveraging the other one. That's something that we'll see. But anyway, this is a couple of things that are overhead that we'll get into. And so it's okay if this doesn't sound too familiar at the moment. We'll get back to that in a few minutes. So the other file that you need, so with this one picture here, you need to have at least 3 files: an interface, an implementation of that interface, and ultimately what you want to have is an application. But to get started, and what I'm going to be showing here is having a driver program. And so a driver program, the difference between a driver program and an application is a driver just has it shows that there is an execution of each of the methods and having some minimal amount of things that are done. And so this is for the driver or the application. This is where you have your main statement. And then I just call these different methods. And this version that I have here, they're all code stubs. And so we're just going to get like a few print statements. And so if I just do an execute, I should just get a couple things here. So this is all we got here. So I'll just let you play around with that a little bit. And I just wanted to at least get you having an idea how this works. So it's kind of what I did is whatever analogy you wanted to use, I took you into the kitchen and I showed you creating a cake or whatever, but I haven't explained all the details, but I at least wanted to spend a little bit of time so that you guys can get a little bit of a sneak preview to get your environment working as we start to do some of our coding. So let me pause and see if there's any questions. And what I'll do is I'll backtrack to some of the lecture material and show at least one video, and we'll be keep coming back to that environment so they can get a chance to see how this is going to help us as we start to code some different abstract data types.
Excuse me, Professor.
Hey, Nathan.
So I have the source code or the package for the bag interface, but I don't know how to put that into Eclipse.
Okay. Let me show you how to do that. So give me a second. Basically, it's a drag and drop function. I have a Mac, and sometimes it's a little bit different than going between a Mac and a PC. And if it is, don't know if I'll be able to do that real time, but I'll get a chance to show you what I mean.
Okay.
So I can actually fire up a virtual machine and show you. So let me double check where I have my file. Okay, what I'll do is I'll just do it like you have to do, and then you'll see what I mean. So I'll just download this sample. And unzip it. And so these are the files that I want to be dragging into a new project. So let me just create let's see. So there's all kinds of fancy settings that you can use. I believe that's all I'm going to need to just show you what this is. So just calling it check. Probably will show up around down here because I got too many things. Okay, so this is the source folder. I think I need that. Let me try and just delete that. So now what I'm going to do is this drag and drop them into the source folder. That's where you want to put them. And it'll say copy the files. That's what you want to have done. And then after that, you have all of those files like I just showed you. Does that help you, Nathan?
Yeah, I tried doing that and it's not letting me for some reason. I don't know why.
It might be a permission issue. I'm not quite sure. I've had that happen before. You may want to, please don't do it now, but later reboot and try it again. But why don't I work with you, Nathan, and let's see if we can figure that out. But I apologize, but I know that can be real frustrating. Eclipse is pretty powerful, but at times it can be. I've had a couple times where it's, you know, something's happened and I wasn't quite sure why, what happened, but anyway, so just delete
Yeah.
that.
This has never happened to me before, like, 'cause I've used Eclipse for my other computer science classes, and it it never does this, because I do like do the drag, like I do drag folders into the Eclipse, but now I don't know why it's not working. It's weird.
Um, do you have a Mac or a PC?
I'm on a PC.
I don't know if there's some kind of something subtle about the files that you might have to change their permissions or something like that, or maybe your antivirus is somehow blocking the files, or where you have your Eclipse environment, does it have the permissions to be dragging files? I know with cybersecurity, there's a lot of things that are going on so I'm just kind of speculating a couple of things that might be something that might be going on. So, but thank you for giving me that heads up. And maybe it'll give a little bit of encouragement if anybody else is having some challenges. We can figure that out together. Okay, I'm going to go ahead and go back to some of the lecture material, because I actually was talking about stuff that I hadn't really had a chance yet to talk in class. But because I know that some people find that getting some hands-on working with stuff is a great way for them to be seen, that would be great. Okay, Connor, yes, all of the classes are recorded, and so you can take your time reviewing that. And I've also have other content that I've tried to show you that I've posted in Canvas that you could take advantage of. So please feel free to do that. So let's just go back and talk a little bit about bags, since I've introduced that. And so once again, when I was showing you the chart that I like to keep going back to, each one of these abstract data types, they have a certain set of behaviors that they do just what they do and nothing more. So you don't need to have a tree or a dictionary or a list just to do things to stick something in a bag and take it to your car. We want to be applying that same kind of approach as what we're thinking about, what we're doing in each one of these. And so we're going to go from simple to more complicated, although there's more methods in bags, and then you'll see as compared in stack and in queue, but that's kind of an aside. So we're going to touch on these things, and let me introduce another thing. I'll come back to this in a second, but let me show you the video content, because I think it's well worth our time to be make sure that we take advantage of this really good resource. And so let me go ahead and start to open this up. So let's start with this one. At least we'll get audio, so that may be booming. I'll finesse it a little bit in just a second.
This lecture builds on the foundation of the object-oriented programming concepts of encapsulation and data abstraction, and it helps develop the notion of an abstract data type. As you probably know, a data type, such as an integer or double, is a group of values in.
So since we didn't show some of the preview videos, I was trying to show them on Tuesday. So object-oriented programming just means that you have a level of abstraction that you can then apply and make more definitive. So you can start out with a generic bag. And so a bag could be a paper bag, a plastic bag, a grocery bag, a bag that you're going to be using on Amazon. And so here we get a chance to start to specify a little bit in terms of some of the behavior that we're looking at.
Operations on those values that is defined within a specific programming language. In contrast, an abstract data type, or ADT, is a specification for a group of values and the operations on those values that is defined conceptually and independently of any programming language. A data structure is an implementation of an ADT within a programming language, and this lecture also begins to generalize the idea of grouping objects together.
So we have abstract data types independent of any programming language. So that's why we talk about these a bunch of ADTs we're doing. And then we have to develop that in a language. So we have to do it in Java. We could be doing it in Python. We could be doing it in C++. But for us in this class, we're going to be doing it in Java. And then we're starting to put that into collections. So those are kind of a little bit of perspective.
Collection is an object that groups other objects and provides various services to its client. Various collections exist for different purposes, and we're going to specify the behaviors of collections abstractly. So a collection is an abstract data type. However, an abstract data type is not necessarily a collection. For an example of a collection and of an abstract data type, let's look at the abstract data type bag. A typical collection enables the client to add items, remove or retrieve items, and query the objects it represents. Let's look more closely at the specific behaviors our ADT bag needs. We need to check the bag's status, so we need to get the number of items currently in the bag and see whether the bag is empty. We need to be able to add a given item to the bag, remove an unspecified object from the bag. We need to remove an occurrence of a particular object from the bag if possible, and we need to be able to remove all objects from the bag, such as when we want to empty or clear the bag.
So some of you are engineers, most of you are computer science folks. And so the engineers, maybe you're more familiar, although it really is cross-cutting. This is like the requirements for what a bag has to do. This is leading to how we start to form the methods and make sure that it's complete. So we're trying to give an abstract idea of what a bag's behavior is going to do and what we're going to call all the verbs, add, remove. These are the kind of things that we're doing.
We need to count the number of times an object occurs in the bag, and we need to test whether the bag contains a particular object. And finally, we need to be able to look at all the objects in the bag. We can take these behaviors and write them on a class responsibility collaboration, or CRC card. So
here we have it in English, the way that we are most familiar with, but we need to translate this into code. And so this is a minimum, an intermediary step that you could use, what they're calling the CRC. And so this is getting into kind of short statements, not quite with what you're going to use as a name for a method, but we're moving in that direction.
Since a bag is an abstract data type, we only describe its data and specify its operations. We don't indicate how to store the data or how to implement its operations. For example, don't think about arrays. We first need to clearly understand what the bag operations do, not how to do them. That is, you need a detailed set of specifications before you can use a bag in a program. In fact, when we design ADTs, we should specify the ADT's operations even before we decide on a programming language. Before we can implement a bag in Java, we need to describe its data and specify in detail the methods that correspond to the bag's behaviors. We'll name the methods, choose their parameters, decide their return types, and write comments to fully describe their effect on the bag's data.
So we're going to get into this unified modeling language. And so we have a narrative, we have a CRC card, then we can move into UML. And believe it or not, in a sense, we were actually using something like this with the interface, because with that interface, it was creating the code stubs that we then have to write. And so this is a way of documenting that information that can be helpful for implementation.
Our eventual goal, of course, is to write a Java header and comments for each method. But first, we'll express the methods in UML, or Unified Modeling Language notation. As behaviors, our methods should begin with action verbs. For example, when finding the number of items in the bag, we get current size. This method returns the number of items, so it should return an integer type. It doesn't need any parameters since it operates on the bag itself. Similarly, isEmpty does not need any parameters. This method is only checking the status of the bag. As a predicate or yes/no question, it can return a Boolean value.
So I know the first time I saw this, it was kind of making my head hurt, but you can see how you're translating this into Camelback format, the way that typically is done in terms of a convention. And if there's anything that's passed to that method and what's going to be coming back, these are how we're translating one at a time, each one of these statements.
To add an entry to the bag, we can call our add method. It needs a parameter of the type of object we're going to store in our bag. For now, we can use a generic T to represent that type. Here we have an interesting design issue. What should the add method do when it cannot add a new entry? At this point, we have two options. First, we could do nothing. We cannot add another item, so we ignore it and leave the bag unchanged. Second, we can leave the bag unchanged, but signal the client that the addition is impossible. The first option is easy, but it leaves the client wondering what happened. The second option is a better one, and it is easy to specify and implement. Displaying an error message is not a good choice since a class should let a client manage all written output. Since adding an item is either successful or not, we could simply have the method return a Boolean value at this time. Later, we'll examine using exceptions to notify the client. The first remove is easy. We could just have it return the item removed. If the bag is already empty, our method can return null. Since the client doesn't know ahead of time what item is going to be removed, the return of an item is important. The second remove method requires us to specify an object to be removed. If the bag does not contain the item, we need to inform the client. Since the client already had to specify the item as a parameter, we can return a Boolean to indicate whether or not the item was successfully removed. Removing all the bag's contents can be a void method. We just want to empty the bag, not retrieve any of its contents. The next two methods report on a specific item and don't change the contents of the bag. Then finally, we want to look at the contents of the bag. Rather than providing a method that displays the entries in the bag, let's define one that returns an array of these entries. The client is then free to display any or all of them in any way desired. This design decision makes our class more portable and independent of display methods, such as needing to determine if the application is console or GUI based. As our specifications become more detailed, they can increasingly reflect our choice of programming language. At this point, we can write Java headers for the bag's methods and organize them into a Java interface for the class that will implement.
So UML is not Java, but once again, this is the next step that we're going to be making. If we were going to be choosing C++ or Python, we could be doing something similar, but now we're going to be using Java as our implementation source. So that's why we're going in that direction.
At the ADT. Remember that a Java interface does not have fields, constructors, or private methods. For now, the items in the bag will be objects of the same class. For example, we could have a bag of strings. To accommodate entries of any one class type, the bag methods use a generic type T for each entry.
Okay, that's what this means. It means a generic. So it could be a string. It could be some type of object. What it means is you're not specifying that, and that's going to be something when you actually use this implementation of this interface, that's when it's going to start to be, that's when you'll be declaring what kind of collection it is.
To give meaning to the identifier T, we must write T in angle brackets after the name of the interface. Once the actual type is chosen within a client, the compiler will use that data type wherever T appears. Here's the syntax example implementing the generic interface bag interface. The class bag must provide an implementation of all the methods we're about to define in the interface bag interface. When we're ready to instantiate or create a bag object, we specify the type of the item we want to store in the bag. In this example, we're storing string objects in our bag. Our methods to check the status of the bag are.
So this is kind of helpful, and this is what happens in the textbook, is they introduce a concept and then they move on to the next concept. And so maybe as you're now doing a little bit more elaborate type of Java coding, it's nice for you to be catching some of these things. So maybe this is the first time you've seen this kind of construct where you implement this, you implement something. And so we're foreseeing the way that we're writing our code that it has to be using certain methods. Then when you start to make real objects, this is where you have to do that declaration, and we'll see how that works.
We're storing string objects in our bag. Our methods to check the status of the bag are independent of the type of items stored in the bag. The add and remove methods use the generic type T for the entry to add or remove from the bag. Since we're not worried about implementation details yet, how these items are stored and removed is not important to us. And last, we have the methods that check the status of a particular entry stored in the bag and the toArray method that returns an array containing the entries in the bag. Just because this method returns an array of the entries does not imply that the items are stored in an array data member of the ADT bag. How we store these data items is an implementation detail and the topic of another lecture.
So just to go back to that for a second, here we're seeing the long version of the interface. For the test code that I was showing you, I took out all these commas. But if you wanted to have a brain jogger about what each one does, this is one of those places that it tells you. And actually in the sample interface files that I've shared with you in Canvas, you'll get a chance to see that when you download that. So all of the interfaces are one of the things that I put here. The ADT interfaces, I tried to take all the ones that I found in the textbook, and so it's pretty current. The ones towards the end, there's a whole bunch, but that gives you a little bit of an idea. So any questions on that? So now we've started to get introduced to how things are organized in the course. So first thing that happens is you typically get to understand what is it that we're talking about. So we'll talk about theory. We'll start to, part of it, we'll get into algorithms and stuff like that. And then we look at the implementation. And so here is a Java interlude that talks about this generic data type that we're seeing with these angle brackets, and so we have that. So we specify the interface with the bag with an interface. We talked about the bag's behavior, walking it from just writing in words, putting it in a CRC, putting it in UML, creating the code stubs that you would be using, and all of that are the things that we're trying to capture. We're going to be getting into iteration as well as recursion, but we'll start with something that's more conceptually easy, and just by talking with iteration. So after the video, looking over this will make it a little bit easier for you to see. And this gets into the second video related to this, and maybe I'll just go ahead and play that one just to finish it off for that part. So we talked about what a bag is, and now this video talks about how you go about testing it. And so this gets into this idea that I talked about, a driver program. So let's go and watch this.
This lecture introduces testing methods that can be used to test implementations of abstract data types. Testing is one of the most crucial activities in software development. Any code we write or modify needs to be tested before it can be used in production or live systems. There are two important goals to testing. First, testing ensures that our class behaves as written in the specifications. This is called verification. The classes that we write are used along with many other classes to create a program, and each individual class has specific actions that it must perform so that the overall program runs correctly. If the class does not meet its requirements, other classes that use this class as a data member or client may fail to perform successfully also. So when an item is added to our collection, in this case, our bag interface implementation, we need to verify that the item was added. When a specific item is removed, we need to verify that the requested item is removed. The second important goal of testing is validating that our class has no errors. Our implementation must work as expected and not lose or modify data outside of its responsibility. The data structure that implements an ADT should be consistent. When items are added to the data structure, they should be added and not lost or break the data structure or how we track items inside the data structure. Testing methods, classes, and programs should always follow some type of plan. Never do haphazard testing. Without a plan that tests and validates an ADT implementation part by part, it is extremely difficult to pinpoint exactly where an error occurs, and so we may break code that was functioning correctly or duplicate tests expecting different results without changing the code that caused the actual problem. A good test plan focuses the testing so it is clear where errors occur or improper behavior breaks methods. There are two methodologies we can use to develop a good test plan. The first is unit testing. In unit testing, we focus our testing on the implementation of specific classes. We want to ensure the class performs as required. By focusing on one class and its specifications, we know that any errors that arise are in this class. Once the class is thoroughly tested, it can be used with confidence in programs and other classes. An important tool in unit testing is the test harness or driver class. This is
So this is where you're seeing that term. And so we're not talking like, go into Uber and just saying thank you to the driver. This is like a way of executing everything that we have within our program.
Class or program that is designed to test a specific data structure and calls all of the data structure's methods and tests them to ensure that the data structure performs correctly, even in extreme situations, such as when our bag would be full and we try to add an item, or when the bag is empty and we try to remove an item. For unit testing, we implement our code in pieces and test each piece before implementing additional functionality. For example, we decide to test the data fields for the class and then implement.
Yeah, let me kind of talk to that a little bit just to give you a context. What I would recommend, especially if this sounds kind of challenging to you, actually, I'll qualify that. I think just in general, write one method at a time. And that's why I was talking about in the very beginning, I had code stubs with just print statements, because you want to go from working code to working code. And so this is if you have like 10 different things going on and you don't know where the error is, it's going to be a lot harder to troubleshoot it. So it's actually going to save you a lot of time and energy if you go about working it from that point of view.
Methods that provide core functionality, such as constructors and methods to add and display items. Then we test those methods before continuing. Next, we implement one or a few methods that are more involved and test those. Once those pass our tests, we continue implementing and testing additional methods until the class is complete. It is crucial that this iterative approach is used even now. Implementing ADTs require classes that are more involved than you may be accustomed to. The programs are going to be more complicated and require more classes also. Implementing and testing code in small parts saves hours of debugging time. System testing follows unit testing. System testing tests how classes work together. This can be done with several related classes, such as those that form a package, or it can be all of the classes that form a program being tested together. System testing often relies on the use cases that were developed during the design phase of building a program. The classes that comprise the program are tested in workflows that would occur during the use of the program. Unit and system testing methodologies guide us in designing our tests, but what exactly do we test? This is where the idea of black box testing can guide us. Black box testing treats the class or data structure being tested as a black box that we cannot see inside. How the black box is implemented is not important, only that the box functions the way it is specified. When the box is fed a certain input, it should respond with a specified output. In black box testing, we are only concerned with functionality of the box or class and the interfaces to it. This means that we can test our data structure based on the interface that it implements, since how that interface is implemented is not important. The implementation is not important to the testing, but the implementation is important when it comes to fixing any errors or bugs and resolving any inconsistencies the testing discovers.
Okay, so black box testing, we know what the interface is. And so when we call a method, we know what should happen. Are we supposed to get something back? Do we get something added to an array? These are the kind of things that we would test. The implementation comes later. That, okay, am I using a bag or, an array or a linked list? Am I using iteration or recursion? We'll be talking about those things as we move forward. Those are the next step. What kind of algorithm are we using if we're going to be doing sorting or searching? Those are some stuff that comes later.
Discovers. And black box testing can be used for both unit and system testing. Now let's look at some of the specifics of developing tests. First, for unit testing, we want to validate the status of our collection after we've added or removed items to our data structure. We want to ensure the bag is full or empty when it should be full or empty. And we want to display all of the items in the bag to validate that each item that should be in the bag is actually in the bag. We also need to validate the status of individual items as we add and remove them. This is a different problem than validating the status of the collection. For example, we may check each item after adding it to the bag and validating that it was successfully added, but the bag may return that it is still empty. In testing any of our ADT implementations, we want to make this distinction between testing the success of adding or removing individual items and validating the status of the entire collection. With this in mind, we can begin to develop a unit test plan for our ADT bag implementation. Let's focus on the methods themselves and see how we can test the functionality of this class. To start, we need to create an instance of a bag to test.
Okay, let's put this in context for what you guys are doing. Now, I gave you the sample code for a generic bag, but it doesn't do anything other than test all of those methods. This is the thing for this first project that you need to add. So if it's one of you guys or gals are going to be a wedding planner, you want to figure out, well, how would I be using a bag to do that? If you want to be looking at the Tour de France that I mentioned, a student did a couple years ago, trying to figure out who was the team that got the most riders first, or you wanted to be looking more on individuals, where and how are you going to be using a bag type of functionality? And so you want to make sure that you include that next step, because that's actually where the rubber meets the road, is it's solving a particular problem that you're trying to do with your code.
Newly created bag should be empty, so we need to check that. Next, we can add items to the bag and validate that the bag has all of the items added. And also check that each specific item is in the bag. If the items we added were added successfully, we can remove random items and then specific items from the bag. Then we can continue adding and removing items, but we want to validate two important boundary conditions: that the bag is full when it should be full, and that the bag is empty when all of the items have been removed. This is a different condition than when the bag is first created and is empty. Now that items have been added to and removed from the bag, if our internal accounting system for the bag has an error, the bag may not realize that it is empty. Three important methods we need to be aware of are the add and to remove methods. These methods change the state of the bag. In our test plans, we want to ensure the status of our data structure is validated anytime methods that change the data structure's state are used.
We're going to get into this a lot. And so saying if you do an addition, let's say that we have an array and you declared it with 10 elements and you're trying to add 11th one. They talked about it earlier. Well, am I going to pass on the fact that that failed? Or am I going to have an auto routine that's going to expand that array? Those are things that we're going to do. Remove, did it actually remove it? Was it able to find it? These are all the kind of things that when we're doing these changing, that we want to verify that that's functional.
Here's a skeleton for a driver program that can test an instance of our bag class that holds string objects. The code for the specific test goes in the main method, and there are several helper methods shown here in orange that can be called to perform tasks we need to repeat.
So we have the generic type, as was mentioned before. Here we're using a specific thing. We're saying that a string. So now, instead of just generic, it's specifically everything else that you're doing is going to be strings.
Several times. A very important aspect of this driver class is that we use the bag interface instead of the specific bag implementation as a parameter to the helper methods. This generalizes our driver so that it can be used with any bag interface implementation that holds string objects.
We'll see that again, but this concept means that, saying like I wanted to go from a string implementation to a linked list, go from iteration to recursion, all things that we're going to be talking about, it's very easy to take one piece of modular code and put a new one, and nothing else is going to break, nothing else is going to be impacting it. So that's a good thing.
Have a set of helper methods that shows us the status of the bag. Show bag stats calls get current size and then reports those to the user. The display bag method calls the bag's to array method and then displays the items in the bag for the user to validate. The add to bag and remove from bag helper methods add and remove items respectively, but also validate that the correct item was added or removed. Looking in detail at the main method, we step through a series of tests that use the helper methods to manipulate and validate the bag. Here we instantiate our bag. Since we are performing black box testing, we are only interested in the interface's functionality, so our test bag is of type bag interface. We cannot instantiate an interface, so we instantiate an object from a class that implements the interface, the class we want to test. After creating the bag, we check to make sure it's empty and display its status. We then add values to the bag and display the items to ensure they were added correctly. Then the bag is empty or cleared, and we add items and check each one after we add it. Following that, the status of the entire bag collection is checked again. With several items still in the bag, the remove methods are tested. Either a random item is removed or a specific item is removed. If a specific item is removed, it must be checked to validate the correct item was removed. When our bag implementation test driver is run, we see testing output that shows the activities our bag was put through.
So we're going to be seeing this as we look through the sample code that we have from the authors and publishers. This is the kind of way things look in a driver. So this isn't, helping us to figure who won the Tour de France in stage number 4. This is just saying that each of these methods worked. And so thus you can see a difference between a driver and an application, the way it's using the implementation of the abstract data type and then having the interface.
The bag's status at various points in the test and validation of the adds and the removes. Once we are satisfied that our bag implementation has passed all the tests and we believe it is functioning correctly, we can do a system test. We combine our bag implementation with several other classes to create a program that performs some real-world function that requires our class. In this example, we create a piggy bank that stores coins. The piggy bank holds all of the coins, but does not organize them.
This is what I actually was sharing this code before when I taught this, and it was actually complicated enough that it confused students when they're still trying to understand having an interface, implementing it, and just getting an idea of what we're trying to accomplish. But this is actually a pretty cool piggy bank. I mean, when you stick in something, it recognizes what it is, so it can be telling you how much money is in the piggy bank. Usually that's something that you can't do. It's just basically a quote bag. You stick it in the bank, and you just wait until it's full, and then you take everything out and count how much you've got. So that's to give you a little bit of an idea of what's in this kind of scenario. And so this is not a driver. We're talking here about an application.
And there may be duplicates. So our bag class is a good abstract data type to use as a data member. The piggy bank class can then be a simple wrapper that lets the client add coins to the piggy bank by adding coins to the bag, removing random coins from the piggy bank by removing a random item from the bag, and then checking to see if the piggy bank is empty by checking to see if our bag is empty. The data member is of the type bag interface. This gives us flexibility in what implementation we use to hold the coins in our bank. In the constructor, we instantiate a bag implementation. If later we find that a better implementation of the bag interface exists, we only need to change this one statement in our class to use that new implementation. Here's a program that uses our piggy bank class to add and remove some coins. We declare our piggy bank object here. And even though we appear to be testing our piggy bank program and piggy bank classes, we are testing also how well our bag implementation performs. On larger programs that store hundreds, thousands, or millions of items, we may want to test several different implementations of our interfaces to see which performs the best with the usage described in a specific example.
I know that was kind of a long video, so I apologize for that. Most of the ones we're going to be looking at are shorter, but maybe that it gives you a perspective on that. So I've showed you the 3 different modalities we're going to be using in the course. We're going to have lecture. We'll have that as a good part of what we're doing. We'll get a chance to be having these video notes to have it's almost like a chance to have another instructor to sit in with us, and we can be dialoguing about that. And then we're going to be doing some coding. And so with that, I think you're going to get a chance to not only learn the concepts, but actually use the concepts and hopefully have that filled in to things that you're going to be using in the future. I've been told on multiple occasions that for those that are going to be going to work for some computer science company, you're going to be asked about data structures. And so the things that we're going to be learning in this class are things that will be helpful for you to succeed well in those interviews. And so I'm looking forward to going through it. And actually, I think it's quite interesting on multiple fronts.